The desert sun beat down mercilessly on the rocky terrain of North Africa in February 1943, where two armies clashed in a landscape that seemed designed for armoured warfare. The Afrika Korps, Germany's elite desert fighting force, had by this point in the war accumulated considerable experience battling Allied armour across the unforgiving sands and rocks of the North African theatre. Their commanders and crews had developed a certain professional disdain for the American Sherman tank, a machine they had studied carefully and found wanting in nearly every technical specification that mattered in tank versus tank combat. When German intelligence officers compiled their technical assessments, the Sherman appeared distinctly mediocre on paper. Its armour plating was relatively thin, especially when compared to the increasingly heavy protection being mounted on German Panzers. The main gun, while adequate, lacked the penetrating power of the weapons being fitted to newer German designs. In direct comparison to the workhorse Panzer IV or the fearsome Tiger tank that had begun appearing on battlefields, the Sherman seemed almost obsolete before it even reached the front lines. German tank crews, many of them veterans of campaigns stretching back to Poland and France, felt a certain confidence when they spotted the distinctive silhouette of a Sherman on the horizon. They knew their vehicles could take punishment that would cripple a Sherman, and they knew their guns could punch through Sherman armour at ranges where return fire posed little threat. Yet something happened at Kasserine Pass that defied this comfortable technical superiority, something that left experienced German officers genuinely puzzled and disturbed. As the battle unfolded across the broken, rock-strewn landscape, German observation posts and forward commanders began reporting tactical movements that simply should not have been possible. They watched through binoculars and periscopes as groups of 5 Sherman tanks maneuvered across terrain so rough and fragmented that the vehicles frequently lost visual contact with each other. Ridges, wadis, and rocky outcroppings separated the individual tanks, placing them beyond line of sight, cutting them off from any direct visual communication with their companions. Under normal circumstances, under the tactical doctrines that governed armoured warfare as the Germans understood it, these separated tanks should have been operating essentially independently, each commander making decisions based solely on what he could see from his own limited vantage point. Instead, the Shermans moved with perfect coordination. They advanced in unison, despite being unable to see one another. When one tank shifted position to cover a particular sector, another simultaneously moved to cover the blind spot created by that shift. They turned, advanced, retreated, and reoriented themselves with timing so precise it appeared choreographed. The movements exhibited a level of tactical awareness that suggested each tank commander somehow knew exactly what every other commander in his unit could see, what threats they faced, and what actions they were taking at any given moment. German officers trained in the traditional methods of battlefield communication looked frantically for the telltale signs of how this coordination was being achieved. They searched for flag signals, the traditional method for visual communication when voice contact was impossible. They watched for signal flares, those colourful bursts of light that could convey pre-arranged messages across distances. They looked for dispatch riders on motorcycles, messengers who might be racing between tanks carrying verbal orders from a central command position. They saw none of these things. The battlefield appeared eerily clean of the usual apparatus of military communication. No flags waved, no flares arced into the sky, no motorcycles buzzed between positions, yet somehow, impossibly, the American tanks continued to operate as though controlled by a single tactical intelligence, as though 5 separate tank commanders had somehow merged their consciousness into one unified decision-making entity. The precision was unsettling, almost supernatural in its perfection. German veterans who had fought across Poland, France, and Russia had never encountered anything quite like it. The explanation for this seemingly inexplicable coordination was indeed invisible, at least to observers scanning the battlefield with binoculars and field glasses. The secret had nothing to do with superior armour that might allow American tanks to survive longer in combat, or more powerful guns that might give them an edge in direct fire duels. The decisive advantage was technological, but it operated in a domain the Germans had not yet fully appreciated as critical to armoured warfare. Inside every single Sherman tank rolling across that North African battlefield sat a radio set, a frequency modulation transceiver designated the SCR-508, manufactured in American factories by engineers at Motorola who had spent the pre-war years designing and building radios for automobiles. These were not crude or experimental devices. They were refined, mass-produced instruments representing the cutting edge of American radio technology, built with the same attention to reliability and performance that went into consumer electronics, because many of the same people and factories were producing both. To understand just how revolutionary this was, one had to appreciate the German perspective on radio equipment in armoured vehicles. For the Afrika Korps, and for German armoured forces generally, radios were specialised equipment, scarce resources that had to be carefully rationed across the force. They were seen as somewhat fragile, temperamental devices that required careful handling and frequent maintenance. Getting enough radios to equip even a fraction of the force was a constant logistical challenge. The German approach, born of both technical limitations and industrial capacity constraints, was to treat radios as command and control tools rather than universal equipment. To the Americans, by stark contrast, radios were simply standard equipment, as integral to a tank as its engine or its gun. Every Sherman carried one. Every crew expected to have one. The American military-industrial complex, with its vast manufacturing capacity and its experience in mass-producing consumer electronics, simply built enough radios to put one in every single armoured fighting vehicle. The cultural and industrial mindset was completely different. This seemingly simple difference in equipment philosophy created, for the first time in the history of warfare, an entire armoured army that could communicate with itself in real time, instantaneously, across distances measured in miles rather than shouting range. Every tank commander could speak to every other commander in his unit. Information flowed freely and instantly. Tactical awareness became collective rather than individual. The implications were profound and, as the war would demonstrate, potentially decisive. The Germans had actually pioneered the concept of tank radios more than a decade earlier. In the 1930s, Heinz Guderian, the brilliant German officer who would become known as the father of blitzkrieg warfare, had recognized the critical importance of communication in armoured operations. Guderian insisted that command vehicles in panzer formations be equipped with radios, understanding that the speed and fluidity of armoured warfare demanded faster communication than traditional methods could provide. His insistence on this point was one of the factors that made the early German successes in Poland and France possible. German command tanks in those campaigns could coordinate movements and concentrate forces with unprecedented speed because their commanders could talk to each other directly. However, by 1943, the strategic situation facing Germany had changed dramatically. The vast demands of fighting on multiple fronts, the increasing strain on German industrial capacity, and the relentless pressure of Allied bombing campaigns had forced uncomfortable compromises in equipment production. Radio sets, which required relatively sophisticated electronics and skilled labour to manufacture, became one of the items that was rationed ever more strictly. The result was that most German tanks by this point in the war carried only radio receivers. They could listen to broadcasts from command tanks and higher headquarters, receiving orders and information, but they could not transmit. They could not report what they saw. They could not call for help. They could not coordinate with neighbouring tanks. They were essentially passive nodes in the communication network, able to receive but not to participate. Only a small number of specially designated command tanks in each unit carried full transceiver sets with transmitting capability. This created a brittle, hierarchical communication structure. As long as the command tanks survived and functioned, the system worked adequately. But when a command tank was knocked out in combat, which happened with distressing frequency given that command tanks were priority targets, whole platoons and sometimes entire companies would suddenly fall silent. The elaborate communication network would collapse into fragments of units that could no longer effectively coordinate their actions. The American approach represented a complete inversion of this philosophy. Every single Sherman tank could transmit. Every crew had the ability to share what they were seeing with other units. If one tank commander was killed or his radio damaged, another commander could immediately step into the communication void and maintain the flow of information. The network was resilient rather than brittle, distributed rather than hierarchical. Knock out one node, and the network continued functioning with barely a hiccup. This fundamental difference in system architecture would prove to have enormous tactical consequences. The technical specifications of the radios themselves reflected and reinforced these different approaches. The German FUG-5 radio sets that equipped their armoured vehicles represented state-of-the-art technology for the 1930s, which was when they had been designed. They used amplitude modulation, the same technology that commercial AM radio stations employed. For their time, they were sophisticated devices. But by the 1940s, their limitations had become painfully apparent in the harsh environment of armoured combat. The FUG-5 sets produced barely 10 watts of transmitting power, a relatively weak signal that could be easily overwhelmed by interference. And interference on a World War II battlefield was omnipresent and overwhelming. Tank engines produced electrical noise that radiated across a wide spectrum of frequencies. The electrical systems in the tanks themselves, with their generators, motors, and ignition systems, created constant crackling static. Artillery shells exploding nearby generated massive electromagnetic pulses. Even the friction of tank treads on certain types of terrain could generate static electricity that manifested as radio interference. All of this noise and interference affected amplitude modulation signals particularly severely. The AM signals used by German radios would be drowned in cascades of static, their weak voice transmissions barely audible beneath the roar of electronic noise. A German Panzer on the move, with its engine running and electrical systems active, might be able to communicate clearly over a distance of 1 to 2 kilometers under good conditions. Under combat conditions, with artillery fire adding its electromagnetic chaos to the mix, effective range could drop to just a few hundred meters. Commanders trying to coordinate their forces found themselves shouting into microphones, trying to make themselves heard over the interference, never quite certain whether their messages were getting through or being lost in the electronic fog of war. American radio sets used frequency modulation technology, a newer and more sophisticated approach to radio communication that offered enormous advantages in noisy environments. The SCR-508 sets installed in Sherman tanks generated 25 watts of transmitting power, more than double the output of German sets. But the real advantage came from the nature of FM signals themselves. Frequency modulation was inherently resistant to the kinds of interference that plagued amplitude modulation. Engine noise, electrical sparks, and artillery-induced electromagnetic pulses that would completely overwhelm an AM signal barely affected an FM transmission. The voice coming through the headphones of an American tank commander was crystal clear, easily understandable even in the midst of intense combat. The difference in effective range was staggering. A Sherman tank could maintain clear, reliable communication over distances of 10 miles or more, even while moving at speed across rough terrain with all systems running. To German tank crews who occasionally intercepted American radio transmissions, the clarity and reliability of those signals seemed almost magical, representing a level of technical sophistication they could not match. The physical specifications of the SCR-508 system reflected the American philosophy of rugged, reliable, mass-produced equipment. The complete set weighed approximately 180 pounds, a considerable mass, but one that could be easily accommodated in the relatively spacious interior of a Sherman tank. The system consisted of multiple components that worked together to create unprecedented capability. The BC-604 transmitter handled outgoing voice communications with robust reliability. The BC-603 dual receiver setup was particularly innovative, allowing tank commanders to monitor multiple radio channels simultaneously. A commander could listen to his platoon's tactical net on one receiver while keeping the other tuned to the company command net or even to frequencies used for calling in artillery support. This multi-channel monitoring capability meant that information flowed not just horizontally between peer units, but also vertically through the command structure and even across to supporting arms like artillery and air support. Each tank became what historians and military analysts would later recognize as a node in what was effectively the world's first battlefield network, a distributed communication system that connected every element of the armored force into a single, responsive organism. The tactical results of this technological advantage became apparent almost immediately when American armored forces engaged in sustained combat operations. In North Africa, where distances were vast and the terrain was often broken and confusing, scattered Sherman units demonstrated an almost uncanny to coordinate their actions across distances measured in miles. Tank commanders could warn each other of enemy movements well before those threats came into direct visual contact. When one unit spotted a German ambush position, that information flashed instantly across the radio network to every American tank in the area. Artillery fire could be called down with remarkable speed and accuracy because the forward observers in tanks could communicate directly with the guns, transmitting precise coordinates and adjusting fire in real time based on what they could see. When German forces attempted to launch coordinated attacks, Shermans could shift position rapidly to meet the threat, concentrating force at the critical point because every commander in the area knew where the enemy was striking and where friendly forces needed to be. At Kasserine Pass, despite the fact that the battle represented a tactical defeat for American forces, who were still learning the harsh lessons of armored warfare against a veteran enemy, German observers noted something that appeared in intelligence reports and after-action analyses. American units maintained cohesion under pressure in ways that should have been impossible given their level of training and experience. Green American troops, some of them seeing combat for the first time, nevertheless managed to coordinate their movements and maintain tactical organization even while retreating under heavy fire. German officers, accustomed to seeing inexperienced units disintegrate into chaos when subjected to the shock of intense combat, could not quite understand how the Americans were managing this. Intelligence analysts attributed it to good discipline and effective leadership, which were certainly factors. But they fundamentally missed the real explanation because it was invisible to traditional military observation. The Americans had equipped their forces with a technological advantage that Germany simply could not match, an advantage that multiplied the effectiveness of every other element of American combat power. When the fighting shifted from North Africa to the Italian peninsula, the advantages of superior radio communication became even more pronounced. Italy's mountainous terrain created enormous challenges for military communication using traditional methods. Visual signaling became nearly impossible when mountain ridges blocked line of sight between units. German radios, already struggling with limited range and poor signal quality, found the Italian landscape particularly hostile. Radio waves would bounce off mountain slopes, creating echoes and dead zones. Signals would be blocked entirely by ridges and peaks. German units operating on opposite sides of a ridge or in different valleys might as well have been on different planets for all the ability they had to communicate with each other. American FM radios, with their greater power and superior signal characteristics, handled the mountainous terrain far better. The stronger signals could punch through or over obstacles that completely blocked German transmissions. Shermans positioned on opposite sides of ridgelines, completely out of visual contact with each other, could coordinate complex flanking maneuvers as though the mountains separating them did not exist. They could orchestrate pincer movements, one force fixing the enemy in place while another swung around to attack from an unexpected direction, all coordinated by voice radio without the attacking forces ever seeing each other until they converged on the target. German tank crews, trained in tactical doctrines that emphasized visual contact and direct observation, found themselves fighting an enemy that seemed to possess almost supernatural awareness. They faced not individual tanks that could be dealt with using conventional tactics, but rather a coordinated organism that responded to threats and opportunities with stunning collective speed. Dozens of Sherman tanks would move, react, shift positions, and call in supporting fires with a rapidity and coordination that left German commanders struggling to respond. The psychological impact of this was significant. German tankers began to feel they were fighting not against individual opponents, but against an intelligence that could see everything and respond instantly to any threat. One significant problem did emerge with the American communication system, however, highlighting a challenge that would recur throughout military history whenever new technologies were integrated into existing force structures. Sherman tank radios operated on different frequencies than the radio sets carried by American infantry units. The two systems, designed and procured separately, simply could not talk to each other directly. In the close terrain of the Normandy bocage, where hedgerows and sunken roads created a labyrinth of enclosed spaces, this communication gap created real tactical problems. Infantry soldiers on foot, moving through the hedgerows, would spot German infantry teams armed with Panzerfaust anti-tank rockets creeping close to American tanks, preparing to launch devastating close-range attacks. The infantry could see the threat clearly, but they had no way to warn the tank crews who were buttoned up inside their armoured vehicles, unaware of the danger stalking them. The solution that American forces improvised demonstrated the kind of practical innovation that characterized the American way of war. Tank crews began bolting standard field telephones to the rear of their Sherman tanks, running wires from the telephone handsets directly into the tank's internal intercom system. Infantry soldiers accompanying the tanks could simply pick up the handset and speak directly to the tank commander inside, warning him of threats, pointing out targets, coordinating movements. It was crude, inelegant, and completely effective. Within a matter of weeks after this field modification began spreading through American armoured units, tank infantry coordination reached levels of effectiveness that German forces could not match. Panzer grenadiers and panzer crews on the German side operated with communication systems that were, if anything, even more fragmented than the American systems had been before the field telephone modification. But the Germans lacked both the material resources and the culture of innovation to implement similar solutions on a wide scale. By late July of 1944, during Operation Cobra, the massive offensive that finally broke out of the Normandy hedgerows, the scale and sophistication of American radio-enabled coordination reached levels that stunned German defenders, who had thought themselves prepared for anything the Allies might throw at them. More than 200 Sherman tanks advanced under the overall command of Major General Edward Brooks, but rather than operating as a single unwieldy mass, they functioned as a fluid network of smaller units that could instantly share information and respond to changing tactical situations. Reports flowed continuously across the radio network like blood through an organism's circulatory system. Enemy armour sightings were broadcast the instant a tank commander identified a target. Artillery targets were transmitted with precise coordinates to fire direction centres that could put shells on target within minutes. Requests for air support, for engineering assets, for ammunition resupply, for medical evacuation, all moved at the speed of electromagnetic waves rather than at the speed of runners or dispatch riders. The German Panzer Lehr Division, one of Germany's most elite armoured formations, manned with experienced veterans and equipped with excellent tanks and weapons, found itself facing Sherman forces that seemed omniscient. A German Panther tank would reveal its position by firing at what its commander thought was an isolated American target, only to find within minutes that artillery shells were raining down on it, directed by tanks that had never even seen the Panther directly, but had received targeting information over the radio network from a tank that had. At Aracourt in September 1944, the contrast between radio-equipped and radio-limited forces reached perhaps its starkest expression. German Panther tank brigades, equipped with vehicles that were technically superior to the Sherman in nearly every measurable way, launched attacks against American positions. the German tanks had heavier armour that could shrug off hits that would destroy a Sherman. They mounted high-velocity guns that could penetrate Sherman armour at ranges where American guns were ineffective. On paper, looking at the technical specifications, the Germans had every possible advantage. In practice, on the actual battlefield, the outcome was completely different. Sherman crews with their ubiquitous radios dominated the tactical engagement. Every tank that spotted an enemy reported its location. Every tank adjusted its position based on the flow of information across the network. Artillery support arrived within minutes rather than hours because tank commanders could call fire missions directly and adjust the fall of shells based on their observations. The results were devastating for the attacking German forces. Over a period of 3 weeks of intense combat, the American 4th Armored Division destroyed 281 German armored vehicles while losing just 41 Sherman tanks, a kill ratio of nearly 7-to-1 achieved not through superior armor or bigger guns, but through clearer voices transmitted across radio waves. By 1945, as the war entered its final phase, the American system of tank radio communication had reached full maturity. Tactical procedures had been refined through years of combat experience. Crews were trained to use their radios effectively from the moment they arrived in their units. The technology itself had been debugged and improved through successive iterations. When American forces, through a combination of speed and good fortune, managed to capture the Ludendorff Bridge at Remagen intact in March 1945, giving them a precious crossing over the Rhine River that should have been destroyed, news of this stunning tactical success spread across American radio networks within minutes of the bridge's seizure. Divisions positioned miles away from Remagen, engaged in their own operations, received the information almost instantly. Commanders at every level could immediately begin shifting forces to exploit this unexpected opportunity. Reserves that had been positioned for completely different operations were redirected toward the bridge. Supply lines were reoriented to support a new axis of advance. The entire massive apparatus of American military power began flowing toward and through the captured bridge with remarkable speed. German counterattacks, organized through a communication system that relied heavily on telephone landlines that had already been shredded by Allied air attacks and artillery fire, arrived piecemeal and uncoordinated, only to be crushed by American forces that had concentrated overwhelming combat power at the critical point. For American tank crews, the psychological and morale impact of universal radio equipment was almost as important as the tactical advantages. Even when a crew found itself isolated, cut off from visual contact with friendly forces, operating in what might seem like a desperately lonely and vulnerable situation, the voices in their headphones assured them they were never truly alone. The radio brought them warnings of threats they could not yet see. It provided updates on the broader tactical situation. It carried words of encouragement from commanders and comrades. Listening to the constant flow of communication, a tank crew knew they were part of something larger than themselves, part of a coordinated force that would support them and respond if they called for help. This sense of connection had real effects on combat effectiveness. Crews fought more aggressively and took more risks when they knew help was just a radio call away. They maintained better situational awareness because information flowed to them constantly. They made better tactical decisions because they understood the bigger picture rather than just their immediate surroundings. For German tank crews operating with scarce and limited radio equipment, the experience of combat was fundamentally different and far more psychologically isolating. Most German tanks by mid-war carried only receivers, which meant their crews could listen to orders from higher command, but could not transmit their own observations or calls for help. They fought as individuals rather than as parts of a coordinated network. Memoirs and post-war interviews with German tank veterans frequently described the profound loneliness of armoured combat, the sense of isolation inside steel hulls that might as well have been on the moon for all the connection they felt with their surrounding units. They described the terror of not knowing what was happening beyond the next ridge or around the next corner, of operating in informational darkness while trying to fight an enemy that seemed to possess perfect awareness. When a German tank ran into trouble, when it encountered a superior enemy force or suffered mechanical breakdown, the crew was often on its own. They could not call for help because they had no transmitter. They could not warn other friendly units of the threat they had discovered. They could only fight or flee based on what they alone could see and know, hoping that someone higher up in the command structure would notice their absence or hear their last radio transmission before they were knocked out. After the war ended, when Allied technical intelligence teams gained access to captured German equipment and facilities, they conducted detailed examinations of German radio technology that confirmed what combat experience had already shown. American radios were assessed to be approximately 5 years ahead of German equivalents in terms of technical sophistication and battlefield effectiveness. The German FUG-5 sets, when examined by engineers who understood the state-of-the-art in radio technology, were found to be fundamentally limited by poor frequency stability that caused signals to drift and required constant manual adjustment, insufficient power output that restricted range and made signals vulnerable to interference, and inadequate signal clarity that made communication difficult even under good conditions. Soviet technical analysts examining both German and captured American radio equipment in the war's aftermath reached identical conclusions about the superiority of American FM technology, and made the decision to copy American designs for their post-war tank radio development rather than pursuing German approaches. The sheer scale of American radio production told a story about industrial capacity and strategic priorities that was perhaps as important as any technical specification. The Motorola Corporation alone built more than 50,000 tank radio sets during the war years, enough to equip every single one of the approximately 49,000 Sherman tanks that rolled off American production lines. The numbers reflected a fundamental American approach to warfare that emphasized equipping every soldier and every vehicle with the best available tools rather than rationing advanced technology to elite units. Germany, facing severe constraints on industrial capacity and raw materials, built fewer than 6,000 full transceiver sets for use in more than 12,000 medium and heavy tanks produced during the same period. The mathematics of this disparity were brutal. The majority of German armour rolled into battle half-mute, able to listen to orders but unable to speak, unable to report, unable to coordinate, unable to call for help when things went wrong. The fundamental lesson that emerged from this technological asymmetry was stark and unforgiving. Germany had indeed built technically superior tanks in many respects. The Tiger and Panther tanks featured armour protection that was substantially thicker than anything the Allies fielded until very late in the war. They mounted high-velocity guns that could destroy Allied tanks at ranges where return fire was ineffective. German optics were generally superior, giving German crews better ability to spot targets at distance. German tank designers had created formidable fighting vehicles that were genuinely feared by Allied tank crews who had to face them. America, by contrast, built tanks that were merely good enough. The Sherman was adequately armoured, adequately armed, mechanically reliable, and easy to produce in vast quantities. But where America truly excelled was in connecting those adequate tanks into a network that allowed them to fight as a coordinated whole rather than as individuals. The result was an armoured army that could concentrate force at decisive points, that could share information instantly, that could call in devastating supporting fires, that could respond to threats with collective speed that individual excellence could not match. In terminology that would not become common for decades, not until the computer and internet age would introduce concepts like networking and distributed systems into common vocabulary, the Americans had built what was effectively the world's first real-time battlefield network. Historians examining the campaigns of World War II often focused their analysis on factors like armour thickness or gun calibre, comparing technical specifications in ways that suggested the side with better engineering should have won. But when one looked carefully at the actual combat results from North Africa, from the Italian mountains, from the Normandy hedgerows, from Aracourt, from the Rhine crossings and the drive into Germany, a different pattern emerged. Victory belonged not to the force with the best individual weapons platforms, but to the force with superior communication and coordination. A lone Tiger tank might destroy 3 or 4 Shermans before being overwhelmed, but the Shermans could call in artillery support that never gave the Tiger a chance to fire. A technically superior Panther might have better armor and a better gun than any American tank. But when 5 Shermans could coordinate their movements and concentrate their fire through radio communication, the Panther's technical advantages became irrelevant. Field Marshal Wilhelm Keitel, one of the highest-ranking German officers to survive the war, is rumoured to have made a remarkably candid statement at the time of Germany's surrender. According to the story, though its historical authenticity remains uncertain, Keitel said something to the effect of, "We knew how to build better tanks, but you knew how to make them work together." Whether this specific quote is authentic or apocryphal, whether Keitel actually spoke those words, or whether they represent a post-war invention that captured a deeper truth, the essential insight stands unchallenged. The SCR-508 radio system, that 180-pound box of electronics and wire and tubes, transformed every Sherman tank from being merely a fighting vehicle into something more significant. It turned each tank into a node in history's first functioning battlefield communication network, a distributed system that could share information and coordinate action at speeds that had never been possible in any previous war. That invisible web of voices crackling across radio frequencies, carrying warnings and orders and observations and calls for fire, proved to be more decisive in determining the outcome of armoured engagements than any thickness of armour plate or calibre of main gun. In the final analysis, electromagnetic waves travelling at the speed of light carried Allied armoured forces farther and more effectively than any amount of steel or firepower could have achieved in isolation. German troops, from the sun-baked rocks of North Africa to the frozen forests of the Ardennes, discovered this technological reality the hard way. Again and again across multiple theatres and campaigns, they faced Sherman tanks that they had been taught to dismiss as inferior, only to watch those supposedly inadequate machines move and strike with coordination that seemed impossible, that seemed supernatural, that defied every principle of armoured warfare as the Germans understood it. They spent years fighting against this phenomenon without fully understanding its source, attributing American tactical success to numbers or air superiority or material abundance, never quite grasping that the real secret was invisible, that it existed not in the realm of steel and explosive, but in the realm of information and communication. By the time German military intelligence fully realized that American superiority in radio technology represented a war-winning advantage rather than just an interesting technical detail, it was far too late to do anything about it. German industry was being bombed around the clock. Raw material shortages were crippling. The massive investment required to redesign and re-equip the entire armoured force with American-style radio systems was simply impossible. The world's most advanced battlefield radio systems had accomplished something that thicker armour and bigger guns could never achieve. They had transformed American armoured forces into something that was genuinely greater than the sum of its individual parts. 5 Sherman tanks with radios were not merely 5 separate fighting vehicles that happened to be in the same area. They were a single coordinated fighting system with 5 separate sensor platforms, 5 separate weapons platforms, and 5 separate mobility platforms, all working in perfect synchronization. Connection proved to be the true weapon of victory, more decisive than the thickness of steel armor, more important than the muzzle velocity of tank guns, more valuable than any single technical specification that filled the endless comparison charts in military intelligence files. The lesson would echo forward through decades of subsequent military development, influencing everything from Cold War armoured doctrine to modern network-centric warfare concepts. But in the 1940s, as American and German tanks clashed across Europe and North Africa, the lesson was being written for the first time in blood and fire and electromagnetic radiation, and the side that understood communication would triumph over the side that understood only engineering.